Okay, so today we're going to look at what we call lines of best fit, or linear regression. We're going to do two lessons. This first lesson is going to deal with lines, linear regression. The others are going to be other different types of curves, actually, that we already know. But let me read a little bit of this. So often, sometimes in science, a mathematical relationship between two variables is desired for predictive purposes. Okay, in the real world, the relationship between two variables is not always a perfect one. Thus, we often look for the best curve that can fit the data. So, for example, and we'll look at this in a second in more detail, but so you collect some data. This happens to be age of a child and then the average weight in pounds. So maybe at age 0 months, born at 7.2 pounds, 3 months, this is the weight and so forth. And then it's plotted. Okay, and it kind of looks like a line. Okay, and then we want to come up with an equation, which we're going to use this Desmos equation on our calculator or our phones to do. But we use this, once we get an equation of a line, we can then predict. For example, this is 15 months. Let's say in 2 years, assuming this is going to stay the same, we can kind of predict the weight of a 2-year-old. The further you go, it might be a little off, but we'll use that equation to predict things. Okay, so this first one, it says a pediatrician would like to determine the relationship between the infant female weights versus her age. Okay, the pediatrician studies 100 newborn girls and finds their average weight at the end of 3-month intervals. The data shown below, there it is. Okay, so part A. Okay, I know you don't have a ruler in front of you, but using a ruler, draw a line that you think best fits this data. Okay, as a general guideline, try to draw it such that there are as many data points above the line as below it. So we're not really connecting the dots. So we're just trying to make a line that best goes through these, and I'd say maybe somewhere around here. Okay, it doesn't have to be perfect. So you can freehand draw a line unless you have a straight edge. Okay, so it looks like I got a point below the line, I got a point above the line. These are pretty close. So there's my line of best fit. Okay, it doesn't have to be perfect. Okay. Okay, part B. So we want to find the equation of this line. Okay, and this one we're going to do by hand. So just kind of review some algebra here. And then after this example, we're going to use our phones, okay, or Desmos. Okay, by picking 2 points that are on the line, okay, not necessarily the actual data points, determine the equation of your best fit line. Round your coefficients to the nearest tenth. Okay, so for a line, in general, what's the equation of a line? Y equals mx plus b. Okay, so we need the what and the what. Okay, we need the m. What does the m stand for? Slope. We need the slope of this line. Okay, so we need 2 points. So we could pick any 2 points. I'm going to pick